condense the given expression. We have this expression in infinite form and we want to write in a finite form. But first of all, we want to release from a radical the first term, and we want to write the whole expression into the rational exponent. And we can write this form. So we can write 2 here, and the rest of the radicals we write in the way how they are. We change nothing. So we just rewrite in them. But here, in the exponent here, rational exponent, I write 1 over 2 because this index is 2, so I'm converting into the rational form the radical. And now the 1 over 2 I'm going to distribute in the first number here, and I'm going to release it from the parentheses. And this one is going to look in this form. 2 in exponent 1 over 2, and everything here stands inside the parentheses in the form how they are. I'm not changing nothing, so I'm rewriting those expressions, whatever stands inside the parentheses. But here is 1 over 2. And the same process I'm going to continue in each following term. And if I'm following here, in this term here, now this 2 times 1 over 2 is going to be time, and the first term here I'm going to write into the rational exponent, this radical, with index 3. So 2 times everything here inside what remains in the same thing. So this one is going to be 2. 4 times 2 in exponent in the index 5. I'm sorry. So I'm just rewriting, so this is a 2, I'm sorry, this is a 2, so this is a 2, and this continues forever. But here is 1 over 3. But don't forget here, because I'm just releasing everything here is in 1 over 2. In 1 over 2. And now I am releasing this 1 over 2 times 1 over 3, and this number 2 I'm writing in the rational form. And this is going to look something this way. 2 in exponent 1 over 2 times the second term is 1 over 2 times 1 over 3. And everything here else remain inside the parentheses, which happens here to be, so this index of 4 times 2, so this index of 5 and radicand 2, and it continues forever, but here is 1 over 2 times 1 over 3. And this process continues. But we have a pattern here, and we can write this 2 in exponent 1 over 2 times 2 in exponent 1 over 2 times 1 over 3, and the next term is going to be 2 times 1 over 2 times 1 over 3 times 1 over 4, so it's continuing this pattern, and the next one is going to be 1 over 2 times 1 over 3 times 1 over 4 times 1 over 5, and this continues forever. And now since we have this pattern here, but when we are multiplying, so let me simplify a little bit. We can write 1 over 2 times, so according to the multiplying the fraction, we can write this one is 1 over 2 times 3, and the next is going to be 1. So I'm explaining every step, so that's why I'm writing a little bit of extra steps. 2 times 3 times 4 times 5, and it goes forever. But now we want this to write into a different form, in the factorial form, and to write into the factorial form we can write this way, because 2 factorial is what 2 times 1 is 2, so this one I can write in the factorial form, 2 factorial. The other one I can write in factorial form 1 over 3 factorial, because 3 factorial is 3 times 2 times 1, but because it's not changing anything, 3 times 2 is a 6, times 1 is a 6, so 3 factorial gives me the same value, 3 times 2 times 1, so I can write in this form, factorial form. And the other one, again, I can write 1 over 4 factorial, and the next I can write 1 over 5 factorial. And it continues forever, and according to the properties of the exponents, this number I can write 2, so the base, because it's the same, and the exponent I can add all the exponents, 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial, and it goes forever. So now I'm going to make a little bit, to explain a little bit about this form, if we have this form here. So just let me write with a different color. So as we know, the series 1 over x factorial from x is equal with 0 to infinity can be equal with 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial. So I'm writing up to 5 because I have here 5 plus, it goes forever. But I want to know just this form. So this part here, what is going to be equal? Because this part I want to know what is going to be equal. But this part is going to be equal here, 1 over 0 factorial. 0 factorial is 1. 1 over 1 is 1. And 1 factorial is 1. 1 over 1 is 1. So 1 plus 1 is 2. So this is everything here. So I'm taking a little bit of shortcut, just a little bit. 1 over x factorial, I can write it is equal with 2 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial, and it goes forever. But now I want to adjust this form. I'm subtracting 2 by both sides. If I am subtracting 2 both sides, then here the series x is equal with 0 to infinity 1 over x factorial minus 2 is going to be equal with 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial, and it goes forever. But now in this expression here, so in this expression I am going to substitute, instead of 1 2 factorial, I am going to substitute this form here. So I have a right to substitute according to the transitive property. So, and now 2 is going to be equal with sigma x is equal with 0 with this theory to infinity 1 over x factorial, and here is a minus 2. But on the other hand, 1 over this series, so we already know the e, so let me write the different color. We already know e is equal with 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus plus, so so this is equal with this series, with the sigma x is equal with 0 to infinity 1 over x factorial. And now instead of this 1 over x factorial, we can write with the e. So who this expression here, so to look a little bit better, so let me write with the blue color. So 2 in exponent e minus 2. So who this expression, what we said before, we can write this is equal with a 2 in exponent e minus 2.